Okay, we have a ball that is thrown horizontally at 8.5 meters per second from the top of a 14-meter high tower. Calculate the horizontal displacement of the ball while it is in the air. This is a horizontally launched projectile. You can tell that because it's launched horizontally. It will follow this parabolic path. It will land down here somewhere, and we are asked to find the horizontal displacement. This right here is d in the horizontal direction while it's in the air. All right, we will start by setting up horizontal and vertical arc charts. So I think I can fit them in here, horizontal and vertical. Okay, what do we have? We'll start with the accelerations as we always do because they're always the same for projectiles. Horizontal acceleration is 0 and the vertical acceleration is 9.8 meters per second squared down. All right, then because this is a horizontally launched projectile, a HLP, we also know that the initial vertical velocity is 0. When it's launched, it's not going up or down, it's only going horizontally. All right, now we start looking at the actual problem, and we'll put in the information that is given to us. The initial velocity here is horizontal, so I put VI is 8.5 meters per second. And the displacement, 14 meters, that's down. We know the ball goes 14 meters down, so I'm going to put D equals 14 meters down. All right, they ask us for horizontal displacement, and so I'll put that as an unknown, D equals question mark. But we don't have enough information in the horizontal arc chart to calculate that yet. We also need time, and we're going to find that from the vertical side. So let's do that first. All right, we have everything we need to use the D under the vertical. D equals VIT plus 1/2 AT squared formula. The initial velocity is 0. 0 times anything is 0, so that side gets arrow zeroed, and we are left with D equals 1/2 AT squared. All right, I can CFU that for T because I want to calculate the time. So I'm going to do that. T is equal to the square root of 2 times D over A. I do that by multiplying both sides by 2 and then dividing by A and then taking the square root of both sides. Okay, we're ready to put in values. T equals 2 times, I can remind myself what that displacement was. It went 14 meters down. And so I have 14 meters. And I have an acceleration of 9.8 meters per second squared. A little note here on directions. I've gotten a little sloppy because I haven't put in a code. I can get away with that because there's nothing that's up in this problem. If I insist on it, I can put a code here, and I'll put down as positive and up is negative. I don't have to do this for a horizontally launched projectile because everything is in the same direction. If I were to do that, I'd have a plus in front of the 14 and a plus in front of the 9.8. Okay, now I'm ready to calculate the amount of time. So I'm going to get my calculator up here. And I have 2 times 14 divided by 9.8 equals 2.85. And then I'm going to take the square root of that, and I get 1.7. That's the amount of time that this is in the air. T is equal to 1.7 seconds. All right, for horizontally launched, by the way, I don't do anything with the whole time or the half time. This is the whole time it's in the air, from when the ball is launched here until it lands here. It travels for 1.7 seconds. All right, now knowing that, 1.7 seconds, I can put that in the horizontal. Time doesn't have direction. I can put the same time in both horizontal and vertical. Now under horizontal, I'm ready to calculate the horizontal displacement. So I'll do that. D equals VIT plus 1/2 AT squared. We have another arrow 0. The acceleration is 0, and 0 times anything is 0. So that whole term goes away. And I'm left with d equals VIT, which is 8.5 meters per second times 1.7 seconds. I'll multiply those on my handy-dandy calculator here, and I have 8.5 times 1.7 is equal to 14.45. I'll round that to 14.5 meters. I am done, and I am happy.